2022, the NIF achieved fusion ignition by focusing 192 lasers on this tiny pellet of fusion fuel, which is encased in diamond and gold, releasing slightly more energy out than the lasers put in. But since then, they've done it 7 more times, and each time they get slightly more energy out. The latest, in April of this year, got 8.6 megajoules out versus a little over 2 megajoules in, for a gain of greater than 4x. Fusion reactors for power are probably still a ways away, but fusion engines for space travel might actually be closer. Currently, we have 2 methods for propulsion. The first are chemical fuels that we use for rockets. These produce a ton of absolute thrust, but they also weigh a lot and aren't that efficient, so you can't just add more fuel if you want to go faster once you get to space by continuing to burn fuel, because eventually the rockets get so heavy they can't even take off from the ground. The second method we use are ion thrusters. By ionizing gases like argon or krypton, you can then shoot them out at really high speeds using electric fields, and that's great because it's really efficient and you can charge them using solar panels, so the lightweight spacecraft can continue to provide thrust for a long time. But the problem is it's kind of like trying to push yourself through space by blowing air out your mouth. You just don't get a lot of absolute thrust out of it. In comparison, fusion thrusters are kind of a great in-between where they're really, really efficient, but they can actually generate enough thrust to move large objects out there in space. This is a prototype design that's being worked on by a UK company called Pulsar Fusion for a space-based tug that would attach to other things once they're in space, and it could shorten the time to get to Mars to just 3 months down from 9, or Pluto to 4 years down from 10 years. The logic behind why this is actually probably easier than a working fusion reactor is that you don't need to capture the energy you produced, and you don't need to worry about leakage, because that's kind of the point. You just need to make sure it's being shot out the back as quickly as possible. Follow me here and on Substack for more science and progress news.